Hi, I'm back again. Right, so now we're going to do some interesting stuff with this tester. We've been through all the basic functions, we've also been through the probe. So now what I'm going to do is I'm going to hook it up to the PACMAN board that I had the last time, and I'm actually going to show you it reading some data from the PACMAN board. Now before I go any further, I'd like to just say thanks very much for all the comments I've had so far, particularly from all the UK VAC guys. It appears my videos aren't too bad after all, which I'm very surprised, to be honest with you. I'm not a professional at this. This is just amateur for me, you know. So anyway, let's crack on, and I'll show you some stuff it's doing with the PACMAN board. So first of all, I've done a few changes since the last time. I've actually switched the tester over so it's running on the external monitor. The reason being for that is so you can actually see it hopefully a bit clearer. I'll explain in some video about how you actually can do that. It's very easy to do. But anyway, I'll switch this around and you'll see what I've done. So as you can see, it's now on the external monitor, and I've got the mouse. That is actually the whole screen that you get on the LCD display, but as you can see, it doesn't fill the full screen of the external monitor because it's set to a certain size, and that's really because of the LCD display. The tester is actually, if I turn this down, you'll see powered up, and I've actually this time around got two connectors plugged in. So connector A and connector B. This is a link cable, or a pod if you want to call it, and it basically just plugs into, if you can see, the PACMAN board down there, which is the processor socket. Now normally there's a Z80 sitting in there, as you probably well know. So I've popped out the Z80, you put in a header, make a few simple connections up to the tester, so you connect the address, the data lines, etc. So it's a pin-to-pin connection. There are a couple of resistors on this connector down here which basically pulls up some of the signals that the Z80 has, but we don't use those. So really all it's got at the moment is all the address data lines. It's got the read lines, write lines, the IORQ, and a few other things as well. But it's simple to do. I say the instruction manual, I'll put in details on how you make these things up. They're very easy, and all processors are going to be the same, so there's no fancy stuff to make up a link cable. Okay, so the PACMAN board is currently powered up and it's running. The only thing is obviously it won't run the game anymore because there's no processor, so the board is basically active as far as video and that's concerned, but it's not doing anything. Okay, so now that's hooked up to the tester, it's plugged in. I've got my probe hooked up as well, and as you can see the address is set to 0000, and the data that it's read this time is F3, which is actually the data it's read back from that address on the PACMAN board. So if I actually go and get this camera back up, hopefully, so you can see it. I'll try and get it so I can see both displays. What I'm going to do first of all is I'm going to read in some data. I think that's about as good as I'll get for the moment. The camera's not very good, so you have to bear with me. So the first thing I'm going to do is I'm going to, if you can see this okay, it's booted up, it says set to Z80, which is very important because it's a Z80 system we're plugging it into. Address loaded 0, data bus is set to input, that's indicated by that there, as you can see, and it's ready. So what we'll do is we'll do what we did on one of the last videos, and we'll change the bytes to say FF, which effectively means it will read in 255 bytes of information, and it will start from that address. Now obviously if I don't do anything, don't do the right address, it will start from whatever the LED display displays. So what we'll do is make sure it works, we'll just click right address, and it hasn't changed on the LED as you'd expect because it was set to that. And to read the data, all you do is just do block read, simple as that, and it will read the data. As you can see, this time around the display down here is flickering, and that's it, read the data. Now as you can see, if I scroll up with my mouse, that's where we left off, and that's the data come in. So it started at address 0000, and you can see there is all the data. It does it in 16, so you get 16 blocks of data per line. So the next address is 0010, 20, 30, etc. And you can see it goes right way down. FO is the next one, and the last byte of data will be FE because the next address the tester will go to is displayed there, which is 00FF, and that's it, basically read that ROM. from that PACMAN board. I've not removed the ROM, as you can see it's just completely read it through the processor socket. It also tells you it's created the data.txt file, and that is created because it's called data, which is there, and it's added the extension .txt, so it's created that. And if I pull that up, I've already got that open down the bottom. You'll see there is the text file it has created, which you can copy and you can paste it, you can do all sorts of things with it. Just anything you can do with a text file you can do with that. And what it's done is just done exactly the same thing. It's put the addresses down that side and it's put all the data, as you can see. So you can use that for comparing or whatever you want to do. And that's how it reads the ROMs. Now if I do another block read, it will kick off, as I said, from 00FF, and it will read another 255 bytes. And there you go. If you look at it again, you'll see that's where we left off. Reading data, that's where it obviously started for the second one, and you can see it starts at FF, and it does exactly the same thing. And you can actually work your way through the memory map by doing that, so you could read all the ROMs that way. Now quite clearly the ROMs on the PACMAN board are 2K ROMs, 2716 EEPROMs, so 255 bytes is obviously not the full ROM. So what we'll do is we'll read in the full ROM, but we'll do an ID check on it, and I'll show you that. So instead of, we'll set this back to 0, okay, and then we'll change the bytes to 800, which corresponds to a 2K EEPROM in hex. And if we do ID check this time, it will take a little bit longer to do because it's reading more data. So it's saying, what it does is it says ID check and info, and it's reading the data, please wait. You can see the displays flickering away as it reads in the data. And we just sit and wait, and hopefully it will come back with some information for you. Very soon now it should be done. There you go. When it finishes doing the ID check, it will beep to indicate it's finished, and as you can see it's actually calculated the CRC value 32 for that, which is a 2COFA0AB. It's come back and told me the board type is a PACMAN and it's a bootleg, and the device is 6E. Now I've already stored that in there, so it knows that, and it says it's checked it against 2184 files, and that's it read that complete ROM, i.e. device 6E. It's done a CRC on it and it's compared it against all the main files and any extra ones you add in yourself, and it's come back and it's given me the information on the board. If it doesn't know what it is, it will then ask you if you want to enter in the data. If you don't want to enter it, that's fine, it will skip it. So you have the option to add it in. So the ROM could be faulty, for example, and you might not want to add it in, but it won't find the ROM against the table of the files it already knows. So you get the option, if you want to add it in you can, if you don't want to add it in it's fine. And that's it reading the ROM. So the next video I'll do some more stuff with it. Thanks again. Alright.